we see more and more of that usage where people actually use ModelKits as a way to hand over their artifacts between data science teams to DevOps teams to application developers so that they do the production, training, integration as they wish.
This is DevOps Paradox, episode number 299, Managing Your AI Workloads with KitOps. Welcome to DevOps Paradox. This is a podcast about random stuff in which we, Darin and Viktor, pretend we know what we're talking about. Most of the time, we mask our ignorance by putting the word DevOps everywhere we can and mix it with random buzzwords like Kubernetes, serverless, CI/CD, team productivity, islands of happiness, and other fancy expressions that make us sound like we know what we're doing. Occasionally, we invite guests who do know something, but we do not do that often since they might make us look incompetent. The truth is out there, and there is no way we are going to find it. P.S. It's Darin reading this text and feeling embarrassed that Viktor made me do it. Here are your hosts, Darin Pope and Viktor Farsic. Viktor, you were around in the early days of Docker, correct?
I was very much around, yes.
Let me ask this question. Do you know how they came up with the idea of building the container image? What was the genius idea that's like, let's stack a bunch of tarballs together?
The company behind Docker at the time was a cloud something services type of company, right? Some small company in France, if I'm not mistaken. And they were doing something like Docker internally, right? And then they thought to open source it, and then they saw the opportunity and completely changed the direction, right? Whatever that company was, it stopped existing. So it's a similar story like what Google is doing in a way, right? It's just that Google didn't open source Docker-like something, but they were also using containers, right? Of some sorts. Today, when you say container, everybody thinks Docker, right? But, namespaces in Linux and all the other goodies.
Well, what's interesting is today we were talking with Gorkem Ercan about KitOps. Gorkem, how you doing?
I'm good. How are you?
Good. Now, the rest of the story will start to unfold here in just a second of why did I even bring up tarballs zipped up. What is KitOps?
Well, KitOps is an open source project that includes an OCI artifact specification and a Kit CLI that for manipulating that OCI artifacts. So the relationship to Docker is today, Docker container is actually an instance of an OCI artifact. And what KitOps does is what we call ModelKits, which is very similar to the container images, is a way to store your AI and ML project artifacts in OCI artifact format. What that actually provides to you is a way to take your data set and your trained model, your code, your documentation, put that all into a ModelKit, and then store them in any OCI registry like Docker Hub, ECR, Artifactory, whatever your registry provider is. The advantage of that is because of some of the properties of OCI artifacts they are immutable. And the OCI registries has been around for a very long time. This way you are now able to essentially version your data set and your model version and your code and your parameters, anything that you can think of in the context of building and running AI ML model in a version that is relatable and that is immutable. On top of that, you actually get all the benefits of using a Docker registry with RBAC and auditing and so on and so forth. Another advantage that you see is OCI artifacts are Docker images too. So you actually have access to all the DevOps tooling that has been created for Docker images over the years. For instance, when we package models into ModelKits, one of the things that we do is we actually sign them using cosine, which is a tool originally created for images.
So what's the difference between using KitOps or whatever is the name of the format and Docker
ModelKits.
ModelKits and Dockerfile, right? I can package everything using Dockerfile. Just copy this, copy that, right?
Yeah. The big difference is ModelKits, you can actually address artifact types directly. For instance, imagine you're using a data set that is gigabytes of image, and you're packaging that with your gigabyte model. So now when you are going to the production, you do not actually want to download your image set, or your data set, but you do want to download your model because that's the one that's going to work for inference for you. So the difference is if you are doing that with Docker, you now have to download all your data set, all your model, and then it runs. Or if you are doing training, now you actually want the data set, but you don't want the model because you're training the model, a new model with the data set. So what ModelKits allows us to do is to be able to address single layers of the ModelKit artifact. So we can actually say, hey, get me this data set, get me this model or this model part, and put that into training or inference containers. I think that's the biggest difference compared to Docker. You wouldn't be able to do that with Docker because of the way the file system on container images work.
So do I understand it right if I would describe it in layman terms? Like it's a way how to package everything together, but then you pull selectively what you need.
Yeah, you can unpack and pull selectively, yeah.
Okay, and then I saw in the docs, it can be, among other things, deployed to Kubernetes. I guess when you pull, you're generating a new image in a way, right? This is a subset of those images or something like that.
Yeah, that we do have that feature, but that's actually not part of the Kit CLI or the KitOps project, but it is part of the registry that we provide, the Jozu Hub registry that we provide. With that one, what we are able to do is, because a ModelKit is an OCI artifact and a Docker container is an OCI artifact, we can actually on the fly create an inference microservice for you. So the moment that somebody pushes a ModelKit into the registry actually has a container image ready for them to run that model as an inference microservice.
Okay, so when you push it to registry, the big one, right, with everything, then you auto-generate inside of the registry smaller images depending on one with dataset model and stuff. Oh, cool.
And you can actually specify what you want it to generate. It can be like, if you want CUDA supported images, then it does that. Or if you don't want CUDA, but just CPU-only images, it can do that. So by just pushing a ModelKit into the registry, you're able to generate all kinds of alternates for your container runtimes.
To me, this sounds like a box meal. I can go up to the counter and get the whole box, or I can go up to the counter if they were out of boxes and I could just get the pieces that I wanted. Why was this a problem that needed to be solved?
It all started with, I guess, all of these things start when you actually run into this problem, right? So when we first started doing our company, we had a lot of model training and serving that we had to do. The way that we were doing it was we were essentially creating multiple models per customer and serving them and refreshing those models periodically as the new data for the customer arrives. So our company has, or the people in our company have a lot of background in DevOps and developer tools. So being DevOps aficionados, I suppose, we built a pipeline that would automate all of this. So one of the first things that we have seen was in the AI ML world, standardization, it doesn't exist. Like everything is There's always some tool somewhere that is doing the small thing that you're trying to do, but those tools never talk to each other, right? So it becomes a very annoying nebula of tools that you're trying to stitch together. So that was the first thing that we learned. The other thing that we learned was there wasn't a good way of keeping the data sets and models in sync so that we know that, oh, this data set and this model are like, this is the data set that we use this model to train this model, and this is the data set that we use to evaluate this model. There were some solutions out there, but nothing actually worked for us very well. So we kind of built something in-house to be able to do that. And it was an earlier version of ModelKits where we were able to relate the data sets with models that we have trained. It all started from there. And after a while, it kind of make our life much, much easier, but much faster for us to do what we were trying to do. We kind of completed the implementation and open sourced it, and that's how it got started. So it was a real problem that we were facing where keeping the data sets and models in sync was challenging.
Why not just have a big gzipped file? Why did you go down the OCI route?
It's the advantage of the registry, right? Now, with a big gzip file, if you don't, like OCI actually is multiple specifications, but one of the specifications is the OCI distribution specification, which is what manages the OCI registries. So with a big gzip file, you may have solved some of that problem, but the other problems still exist, which is like, how do you have access control? Now you have to implement the access control. You have to implement the auditing yourself. You need to store the gzip file in something like S3 and then implement all that machinery for it, right? So that was the reason why we chose not to do it that way. And with a large gzip file, I don't think we would be able to just get one part of it without actually writing our own tool again.
So it's interesting to me that you chose the landing place, which then sort of dictated what the artifact needed to be. You said, it sounds like a Docker registry is what we need to use to store this. Therefore, you needed to create a container image-like thing to go into the registry. Or did you do it the other way around? Did you say, oh, the container image, that gives us all the layers that we need. We can pull that out. And the logical place to put that is the registry.
I think the thought process was the other way around. Like we started from, we did something like a Docker registry, Docker images. We didn't actually think about the registry at first. And then our first thought was, this could be like containers. And then we looked at it a little bit more and said, okay, containers by itself is not going to work well. So we came up with the OCI artifact that we used initially. Yeah. But the registry was not the first thing that we thought. It was not like we were looking for a way to relate and create an immutable relationship between data sets and models.
Which seems logical to me, because wouldn't you want to be able to prove what made the model instead of just saying, here's my... Now, you just said this could be multiple gigabytes, but I'm thinking, couldn't it be multiple terabytes or petabytes? Where does this start to fall over?
Well, I don't think there is the challenge for ModelKits is not... means of size is not very different from any other means of storing them, right? At the end of the day, a Docker registry essentially stores them in an S3 bucket, very likely. And today, if you look at any cloud solution, large files end up getting stored in S3 buckets as well. So I don't think from that point of view, it's very different from any other solution out there. But the challenge is definitely real. Now you're trying to move terabytes of data into your training clusters. And usually the training clusters are really, really expensive. So you do not want to starve your training jobs out of data as well. So there are challenges like that as well. The ModelKit does not particularly add any layer on top of that compared to any other storage solution, essentially. At least not yet.
At least not yet. What does that infer?
Well, we released ModelKits in February. So this is a very young project, right? And as people and companies start to adopt ModelKits, we recognize new features that are needed. Some of them, they come to us and ask on the open source project if we could have this, if we could have that. So far, nobody asked about a way to split terabytes of data. But, I mean, it's just a matter of time, I suppose.
So you're talking about in the world of ML. Let's just stick that. Forget about AI because that's just a specific form of ML. In the world of ML, there is no standardization. And yet you're trying to bring in a whole heck of a lot of standards. With a ModelKit, are people, you said people have been putting in some requests, but are people accepting of this, or is it still extreme Wild West?
It is still Wild West. The companies, especially when enterprises are trying to adopt their AI ML practices, they see the benefit. We see more or easier adoption on regulated industries because they actually are obligated to keep the provenance and attestations of their software, their AI and ML models, and be able to provide them. I think in EU it's 10 years. I can't remember the legislations in US, and there are several of them essentially at the moment. So those regulated industries actually, they are more easier at adopting something like ModelKits because it provides them a lot of value. They are able to attach SBOMs. They are able to sign these models. They are able to attach documentation to these models and these data sets. So there are advantages to them when they are doing that. So is it at the level of being a standard? No, but it has been 7-8 months that it existed. So we're making progress towards getting larger adoption, but I don't think that it is a standard yet. But yes, we are shooting for something very ambitious in here.
What approach do you take towards making it a standard? Simply by adoption or working with some groups that are establishing standards? How do you envision the ideal situation? How does that happen?
Yeah, that's a good question. So far, our approach has been encouraging the adoption and keeping it open source. It's an Apache 2.0 licensed project. So I guess one of the steps that we are discussing is to take the project into an open source foundation. Something like CNCF, Linux Foundation. We haven't really made a decision in there. The open governance would actually help with the adoption as well, or anyone who has doubts about the project would put them in ease. That's our next step, I suppose, towards standardization. There is a part of it is AI and ML is changing very rapidly at the moment. I was when the cloud started, I was at Red Hat at the time. And Kubernetes adoption started. And that was fast, but this is faster, much, much faster. Trying to come up with a standard that is put in stone may not actually work yet.
But it seems like the base pieces are already there because you're able to build ModelKit. But the other thing is they've been there for decades.
Yeah.
Not all of it.
Right.
Yeah. It's like there isn't. The biggest thing that's new to me out of this whole AI side of things is the hardware class that we have to work with now. We had GPUs in the past, but nothing like what we have now. But I think back 10 years ago, it was like, okay, how do I get this to work on whatever hardware I have? And it was like, okay, well, whatever. But now it's sort of like we used to be able to not do anything with Raspberry Pis. Now I can run AI on the Raspberry Pi. Right? I can run models. Let's put it that way. So if I'm working on building out a model, so who is KitOps for? Because it sounds like it's not necessarily going to be the data scientist, but yet the data scientist needs to use it. It doesn't feel like it's going to be the infrastructure person, but the infrastructure person is going to have to deal with it because of the registry. Who is it really for?
It's for the platform engineering teams to essentially create the solutions for the personas you just mentioned, right? It's like for the data scientists, the only time that they actually need to deal with ModelKits is at the time where they are done with their experimentation and they want to package it and hand it over to the pipelines for further processing, right? It's like usually the way that it works is like they maybe actually be doing some local experimentation, and now it needs to be made sure that they record it essentially so that it is stored in immutable storage. There is access control and so on and so forth. So at that point, they actually need to deal with the ModelKit. But before that, they are happily working with the tools they already like and like to work with, most likely with notebooks. After that, actually, it's taken over by DevOps engineers where they can actually create containers and other kinds of deployments for these models, these data sets and code so that they are able to train it or create inference services. Another way to look at it is, I have a data scientist who created a ModelKit, and now I'm an application developer who needs to use that model together in my application. Usually that handover needs to happen as well. So we see more and more of that usage where people actually use ModelKits as a way to hand over their artifacts between data science teams to DevOps teams to application developers so that they do the production, training, integration as they wish.
It seems like a fairly logical thing. People can just run what part of the ModelKit that they need. I want to go back to one of the things that you were talking about earlier in the EU, and the dates may or may not be roughly. So they have to keep things for 10 years. But EU also has this thing called GDPR. And if my personal data is buried somewhere in training set somewhere, how do I get that out of that? I mean, what am I going to do?
Yeah, that's a very good question. And I don't think anyone in the industry has answered that yet. First of all, your GDPR, any of your information that is subject to GDPR should not end in a data set. But then if it does, and let's say that your data that is subject to GDPR has been in a data set that was used for training a model 5 years ago, how would you discover that?
Maybe when the model is being queried and all of a sudden all of my information shows up.
Yeah, well, a 5-year-old model is probably gone. Nobody is using it. So how would you even discover that, right? It's like, and that's actually one of the things that regulated industries like, because just like container images, you can attach SBOMs to ModelKits. So if you have an SBOM, you actually have a structured data describing your data set and your ModelKit. So if your data set information has enough lineage data, you can actually predict that, the data that we have used for training model X may actually have personal data in it. Without it, what's your standard way of finding out what happened? It's more like, it's like, if you don't have an SBOM, you need to go to all your Maven files, all your NPM files to find if you are affected from a CVE, or you can have an SBOM and query all the SBOMs and see if you are using the infected version. It's very similar to that concept, right?
True, but and I might be completely off the rails here, right? Let's say that you do find that, okay, in datasets starting from January 2022, we found Viktor's data, should be removed. I can imagine how somebody could remove it from a dataset. I cannot imagine how somebody would rebuild all the models because of me.
It depends on the data set. Some of the data sets are used for training. Some of the data sets are used for evaluation. I mean, if your data is part of the evaluation data set, then yes, that it is possible that you can just rerun your evaluation jobs again and repackage your models and you're done. But yes, with training, yes, you have that problem. I have been looking at the legislation so far. I don't think I have seen anything that suggests that they need to retract the model if there are any GDPR information used for training. But on the other hand, we actually do not really know if there are GDPR information used on most of the models today. The amount of information made available to us for training LLMs especially is very limited.
I'm thinking through solutioning right now because it's what I do. It almost feels like the Kit CLI needs some sort of extension to where I could plug in, go scan this for, I'm thinking like you're looking for secrets in a repository, right? That type of thing to where I could extend Kit to give it these other things. And you were talking about trying to get more adoption. It's like if there was I'm going to air quote this plugin model or extension model to where I could bring my own things to Kit. Because yeah, sure, I could do all that stuff up front in a pipeline, but it sure would be nice to be able to just live inside of one CLI if at all possible, because I'm local. It's like, okay, I'm getting ready to do a new model build. Let's check the data set. That could be a different thing, but having it within my little Kit world would be nice.
Yeah, we actually considered that as well. It was early days, so we didn't go for it yet. But yes, the advantage of a ModelKit is you have everything that you need to manage your AI ML project. So as part of that, you can actually have plugins that can bring in different functionality to work with those ModelKits. Yes, I think you're right on the money with that plugin model.
There's pluses and minuses to that. But again, your final artifact now is a complete bundle of everything you need. So it seems like the CLI should be able to do everything you need as well.
Yeah, that's true. Well, actually, the first thing that we were asked about was experimentation tracking, whether Kit would actually do something for that. At the moment, we do not have any active plans towards it. But even if we do, we would probably use a plugin model to bring in that functionality.
For those of us, because I don't live in ML at all, Viktor doesn't either, what is experimentation tracking?
Okay, so an experiment in AI ML world is you have a code for training your model, and you have a data set for training that model, and then you have a data set that is separate data set for evaluating that model. And you have certain parameters that you use in training. So you take all these variables, you do a training, and you do an evaluation. And that's an experiment. And because the AI and ML is indeterministic, you actually need to do another experiment, possibly with different hyperparameters, and then get another result. So the experimentation tracking, what it does is it records your results, and then you're able to compare them with each other. For instance, the experiment 1 created, let's say, that 0.5 result, and then the experiment 2 created 0.7. So the parameter set used for the experiment 2 is a better fit for the data set that you were using. The critical part is you want to create an evaluation data set that is uniform between your experiments. Therefore, you are able to actually compare them. And you do a lot of iterations of that because of the way the the AI ML works, you do a lot of iterations of that before coming up with a champion model that seems to work well with your data set.
That sort of makes sense. I'm rewinding 30 years ago, creating a new data model. We have data inside of it, and then I'm going to run a bunch of queries and get the expected results out of the back. Is everything working okay? It's a variation of that concept.
Or automation.
Or automation around it. Yeah. So here's my question around that. So we're talking about, okay, we run our evaluation data set against it. We get back the answers, and then we're comparing our answers over time as the model changes. But how do people do that today? Are they just piping standard out and then comparing standard out?
Yeah, well, I guess at some point they did, but there are tools like, I guess the most popular one is MLflow, essentially out of Databricks. So what the MLflow does is it provides a bunch of functionality and APIs that you can use for recording your experiments as part of your code. It does specific work on experimentation tracking. MLflow itself is open source, and there are similar, the ones that I can't even remember the names, similar tools out there that also helps with experimentation tracking. To tie it back to Kit, that's why we kind of looked at the plugin model, because we didn't really want to implement experimentation tracking for models, because MLflow is a very complete open source project, and the others are pretty complete as well. I'm sorry that I can't remember the names. So we thought that, okay, perhaps it's just a plugin model that works with MLflow and other tools.
It almost feels like, maybe this is a complete mashup, it almost feels like OpenTelemetry would be part of the solution here.
Yeah, okay. So...
Oh, I stepped in it. I hear you're laughing. I stepped in something. Okay, go ahead.
Yes, you did. It's one of our, and probably others as well, a big part of AI and ML is observability after production, right? With your regular applications, you send your application to production and you observe your performance, your memory usage, or something like that. But the number of parameters that you're actually observing out of your application are limited, and they don't usually change unless something actually goes wrong. Something needs to drastically change for your parameters to change. In AI and ML world, when you send a model to the production, you actually need to constantly observe your AI and ML model, because your models is going to drift as your data changes, because your data is never constant. It changes, and your AI and ML model that was working perfectly for 5 months start to give you results that are not within the acceptable parameters. So there are AI ML observability solutions out there. One thing that we always thought and started doing ourselves is they actually need to be OpenTelemetry compatible. These tools, they need to send the data to OpenTelemetry acceptable formats so that anyone can integrate that tool set with anything that can consume OpenTelemetry, right? So one of the things that we started doing is earlier I mentioned that we are generating these inference microservice containers for ModelKits, is we actually add an OpenTelemetry based observability into those containers. So if you have a OpenTelemetry compatible observability stack, you can just hook those containers, including any AI ML related data, which works really well for LLMs at this point, to your observability stack, essentially by a few configuration changes. I see a trend coming in as the industry starts to adopt more and more AI and ML into production, because people who are actually creating the AI and ML models and people who are actually using them in production are not the same people. So far, we have been getting away with this sort of lack of standardization because of the frequency of these, but now as the frequency of getting things into production goes higher, I think the standardization will become more and more subject of AI ML deployments.
The interesting part in what you just said there is the people that create the models are typically not the one that use it. I think we can say that for anything in software. The people that write the software typically aren't going to be using it. Websites sort of held out, but this is just the same story, third verse.
Yeah, well, yes, and that's exactly why we actually created these 3 different iterations of trying to correct that, right? It's like there was the whole 2 pizza teams which included people who actually deployed the product. It was the software development team's responsibility to deploy and observe as well. I think it worked in some organizations, it didn't work in many organizations. Then we had the platform engineering, which is creating tools for the software development team so that they are able to take their software into production as the DevOps engineers expect to make it easier. So yes, I think I agree with you. The challenge was the same, but the skill set is like with the software developers, you actually had the skill set a little bit far away from what you would get with the DevOps engineer. But with the data scientist, it's actually further away. So the challenge of bridging that gap is actually much larger.
Because all they know is Python? At least they know the command line, right? I mean, that's...
No, well, they do Python, they do command line. They don't even want to do Docker, essentially.
Nor should they have to, right?
Exactly. So we kind of got software engineers to start using Docker a long time ago. And now we are kind of trying to get to a state where it's like, oh, data scientists, now you need to start using Docker. And in my experience, that is not really their strong suit. That's not where they want to work, actually.
And that's okay. But that just means that, well, with Kit, though, if they're willing to work with Kit, they don't care what's happening under the hood, as long as Kit gives them what they need.
No, I mean, it's basically one Python call or one command line call that says, oh, Kit pack and this folder, and it just packs it for them.
Yeah. Because they were probably used to using 7-zip or something else to move data around before, so now it's just a variation of that story.
Exactly. It's exactly like that. But now it's immutable and has an RBAC on it.
Which they don't care about. They might care about immutable, they don't care about RBAC.
Yeah, they don't, but I'm sure the organizations that they work for do.
And that's a nice way for the organization to enforce what they need from an organization perspective to keep people out of jail, basically.
Yes, and also not fiddle with the productivity of your data science team. Now, they don't have to worry about how do I maintain RBAC for this and how do I do auditing for this and all that sort of concerns. They don't have to fiddle with that because those are already taken care of and has been working for that organization for over a decade.
So you're currently the CTO at Jozu.
Yep.
How does Jozu fit into all this?
So at Jozu, we create tools that enables platform engineering for AI and ML projects. So one of our first product around this is the Jozu Hub. And Jozu Hub is essentially a Docker registry, or it is a ModelKit experience layer that is built on top of any OCI registry. Depends on your need. If you already have an OCI registry, it will just work happily with an existing OCI registry and provide information features that are related to ModelKits. Another thing that we are working on right now is what we call the Jozu control plane. And what it does is it actually treats all your workflows, all your ModelKits, all your Docker images, and anything that you can think of that is related to your MLOps pipelines as data planes, and basically provides a way to coordinate them together so that when you're doing AI and ML, because you're doing a lot of experimentation and you need to be able to observe your models in production, the challenges of the workflows is much, much higher compared to your traditional applications. So what Jozu control plane is trying to do is to give you a complete view of your applications and your AI and ML assets. Therefore, you can manage them in a way you can roll them forward, you can roll them back, you can run training pipelines, you can do auto evaluations, auto trainings, and so on and so forth, that sort of thing, and you don't lose the sight of the complete picture. So Jozu, 2 products. Jozu Hub is our registry for ModelKits, and Jozu Control Plane is our way of managing your AI ML applications.
So all of Gorkem's information will be down in the episode description. Gorkem, thanks for being with us today.
Thank you for having me.
We hope this episode was helpful to you. If you want to discuss it or ask a question, please reach out to us. Our contact information and a link to the Slack workspace are at devopsparadox.com/contact. If you subscribe through Apple Podcast, be sure to leave us a review there. That helps other people discover this podcast. Go sign up right now at devopsparadox.com to receive an email whenever we drop the latest episode. Thank you for listening to DevOps Paradox.